Hi guys, my name is Minhajri Ansari and you're watching another tutorial on C programming, and today I will be implementing pointer arithmetic in Visual Studio. So in my previous two videos, I talked about the theory behind pointer arithmetic. So those of you who haven't watched those videos, I recommend you watch those videos first before you watch this video. So first things first, I'm going to define my integer variable num of size 5 and I'm going to initialize it to 1, 2, 3, 4 and 5. And now I'm going to define my integer pointer and I'm going to store the address of the first element inside my integer pointer. And now what I'm going to do is that I'm going to simply call the printf statement and I'm going to print the address inside pointer ptr, and I'm also going to print the contents at the address stored inside PTR by using my dereferencing operator on the pointer variable PTR. And just add a new line here as well to make it more clear to read. And now what I'm going to do is that after that, I'm going to increment my pointer using the increment operator. And then again, I'm going to copy these two printf statements and I'm going to paste them after incrementing my pointer. So when I run the program, so this is the initial address. This is the initial address stored inside the pointer variable. And this is the address of the first element of the array. And when I dereference the address, I got the first element of the array. And then after that, when I incremented the pointer variable by 1, the value increased by 4. So when you add 4 to this hexadecimal number, remember, this is hexadecimal addition. And I talked about hexadecimal addition in my previous tutorial. So check that out if you don't know hexadecimal addition. So simply when you add 4 to this hexadecimal number, you get a new hexadecimal number, which is this. And when I dereferenced this address, I got the element 2. So the point when I incremented the pointer variable, what happened is that the address increased by 4. And when the address increased by 4, since the elements of an array are adjacent, so when the address increased by 4, the new address was actually the next element inside my integer array. So this is how the increment operator works on pointers. Similarly, the decrement operator works the same way. So what I can do is that I can increment my pointer right here, and then I can decrement my pointer, and this will again point to the first element, and this will store the address of the first element of the array. So when I run the program, first, it's going to print the incremented address and the element at that address, and then it's going to print the decremented address, the address of the first element of the array, and the element at that address. And this is the address of the second element of the array because I applied the increment operator right here before printing the address. So this is how this is the basic idea behind pointer arithmetic. And now you can add anything you want to pointer. So for example, I'm going to add 2 to my pointer variable. So I can do it like this. So let me just erase this right here. So this right here, the plus equal to operator simply means PTR is equal to PTR plus 2. So don't get confused by this operator. So now when I run the program, initially the pointer is pointing to the first element. It has the address of the first element. And now when I add 2, so 1, 2, so the pointer will now have the address of the third element of the array. So it will be pointing to the third element, and when I dereference that address, I will get the element 3 in my output screen. And this is the address of the third element. So, you can add any constant you want with pointers. And now let's talk about binary operators involving two operands in which both operands are pointers. So let me define another pointer, and I'm going to name it PTR2, and I'm going to name this PTR1 for simplicity. And I'm going to simply initialize it to the address of the second element of the array. And remember, indexing starts at 0. So now I can only do the subtraction operator on the subtraction binary operator when both of my operands are pointers. I cannot do any other binary operator. I cannot apply any other binary operator if both operands are pointers. And let me show you what I mean. I'm simply going to, first of all, I'm simply going to printf %d. First of all, I'm going to apply the subtraction operator. So I'm going to subtract ptr2 and ptr1 from ptr2. So now what will happen here is that I will get the difference in integers between the two addresses. So I already talked about this in my previous tutorial. So since there is only a single integer difference, a single element difference in between both addresses. So when I subtract ptr1 from ptr2, I'm only going to get a 1 in my output, which is an integer. So let me run the program and you see the 1 right there. Similarly, if I change the address of my ptr2 pointer, suppose I make it point to the third element. So I change the index to 2. So now the difference between the pointer pointing to the first element and the pointer pointing to the third element, the difference in between them is of 2 integers. So when I run the program, I'm going to get 2 in my output. Remember, this is pointer arithmetic. So you're not actually subtracting addresses. You're subtracting the difference of integer elements in between those addresses. So you can only use the subtraction operator. Now, if I add the addition operator right here, I will get an error because I cannot add 2 pointers. If I try to multiply 2 pointers and try to run the program again, I will get an error. So I cannot multiply 2 pointers. Similarly, I cannot divide 2 pointers. So when I run the program, again, I'm going to get an error. So just proved my point. I can only subtract 2 pointer operands. So now the final thing, we're going to talk about relational operators on pointers. So again, what I'm going to do is that I'm going to write ptr2 is greater than ptr1. And now the relational operator is simply used to check the relative ordering of elements. So ptr2 actually points to the third element. It has the address of the third element of the array, and ptr1 has the address of the first element of the array. So since the third element, the index of the third element is ahead of the index of the first element, so this will be true. This will give me a 1 in my output. This will evaluate to true. But if I write a false condition, if I write ptr2 is lesser than ptr1, this is wrong because it is not. The index of the third element is ahead of the index of the first element. So when I run the program, I'm going to get a 0 in my output. Similarly, I can check if 2 addresses are pointing to the same element by using the equality. So when I run the program, again, I'm going to get false 0 because pointer 2 has the address of the third element and pointer 1 has the address of the first element. So if I write not equal to, if I test inequality, so now when I run the program, I'm going to get a 1 because pointer 2 is not equal to pointer 1. So I mean, simply the relational operators simply check the relative ordering of the elements in the array. It does not actually compare the actual values of the address. And one thing to keep in mind is that the pointers must point to the elements of the same array. So suppose let me define another integer variable num and let me initialize it to 5. So now if I assign pointer ptr2 with the address of, no, let me do num1 because I cannot have the same names. So if I assign the pointer ptr2 with the address of num1, so now when I try to subtract it, ptr1 from ptr2, this will not work. So when I run the program, it will give me a baseless garbage value because it does not make any sense to subtract 2 pointers that are not of the same array. So I mean, only apply pointer arithmetic or pointer relational or logical expressions on the elements of the same array. in order for it to make sense. So that is all it about a pointer arithmetic and pointer applying relational and logical operators on pointers. And I'll leave the logical part to you. So just try to apply logical operators on pointers, the double and, the and, or, and not, and try to check the results for yourselves. And if you have any questions, please ask them in the comment section. And thanks for watching this video. Just one more thing to keep in mind before I switch off. Remember, pointer arithmetic, you should only apply pointer arithmetic on pointers that point to the same, the elements of the same array. Do not try to apply pointer arithmetic on different integer variables that do not belong to the same array, or else you will get an answer which will not be correct or which will be useless. So thanks for watching this video.